February 20th, 1943, north of Kasserine Pass, Tunisia. The battle report would never fully capture what German tank commanders saw that morning. American Sherman tanks executing maneuvers that defied everything Wehrmacht doctrine deemed possible without visual signals. Through the dust and smoke of the North African battlefield, 5 Shermans separated by broken terrain, with no line of sight between them, converged on German positions with timing that seemed supernatural. No flags, no flares, no dispatch riders racing between vehicles, yet they moved as one organism, each tank covering blind spots the others could not see, each crew knowing exactly where their comrades were. In Panzer IVs equipped with Forg 5 radios, German commanders strained to hear their own leaders through static that overwhelmed their amplitude modulation systems. The 10-watt transmitters, state-of-the-art by 1930s standards, barely carried a few hundred meters when tanks were moving. Most German machines carried receivers only, unable to report what they saw or call for aid. The Americans, meanwhile, fought with technology the Germans did not realize existed: frequency modulation radios in every tank, crystal-controlled precision, 25 watts of output, and clarity that sliced through engine noise and battlefield chaos like a knife through paper. 8,000 miles from Detroit's assembly lines, the most decisive technological advantage of World War II was making itself known, not in armor thickness or gun caliber, but in the invisible electromedica waves linking every American crew in ways the Wehrmacht never imagined possible. The transformation had begun on July 22, 1941, when the U.S. Army standardized the signal corps sets SR-508, SR-528, and SR-528 for all medium tanks, while German forces advanced into the Soviet Union using tactics dependent on radio contact between command vehicles. American engineers at the Galvin Manufacturing Company, later known as Motorola, perfected FM technology that rendered German systems obsolete. The team included Daniel E. Noble, who envisioned FM in military vehicles, and Henrik Magnuski, the principal RF engineer, who solved the challenge of installing complex electronics inside a tank's brutal environment. Their creation weighed 81 tons and transformed every Sherman into a node in the world's first battlefield network. The BC-604 transmitter delivered 25 watts of power, 2.5 times the German Folkem Hive's output. Operating in the 20.0-27.9 MHz range, it provided 10 preset channels with crystal-locked stability. The dual BC-603 receivers in the SER-5 allowed commanders to monitor multiple frequencies at once, a capability that proved decisive in combat. But the true revolution lay in frequency modulation itself. Edwin Armstrong's FM license to the military eliminated the static and interference that crippled AM systems. While German radios picked up every electrical discharge as noise, American FM radios delivered clear voice communication even during artillery barrages. On November 8, 1942, Operation Torch brought American armor to North Africa. The 2nd Armored Division's tanks landed near Safi and Fadala equipped with SER-50. It would soon demonstrate overwhelming superiority over German communications. The Afrika Korps, despite being the Wehrmacht's most experienced armored force, operated under crippling limitations. A standard German tank platoon of 5 vehicles carried only 1 or 2 Fokker 5 transceivers, capable of both transmitting and receiving. The remainder were fitted with Fokker 2 receivers alone. These tanks could hear orders but neither respond nor report enemy positions. German platoons functioned through rigid hierarchy. The leader transmitted orders, and subordinates acknowledged only through action. Once the command tanks, easily recognized by multiple antennas, were destroyed, the entire platoon lost coordination. This weakness proved catastrophic against American forces, where every Sherman carried a full transceiver and could assume command instantly. At the Battle of Kasserine Pass, February 14-24, 1943, American radio superiority received its first major test. Though tactically a German victory, The battle revealed capabilities that stunned Wehrmacht observers. Scattered elements of the U.S. 1st Armored Division maintained coordination across 50 miles of battlefield. Tank crews who had never met worked together, coordinating attacks, issuing warnings, and calling artillery support through crystal-clear FM channels. German signals intelligence intercepted these transmissions and reported their exceptional clarity. The 10th Panzer Division's intelligence section noted that American units maintained contact at ranges where German sets produced only static. More disturbing still was the discovery that every American tank transmitted freely, not just commanders. German Fugab radios, operating on amplitude modulation between 27.0 to 33.3 MHz, struggled under severe limits. Their 10-watt transmitters barely reached 2 to 3 kilometers in ideal conditions, often reduced to a few hundred meters, while moving. Every spark plug, every electric motor, every clattering track generated interference AM systems could not filter. In September 1943, American armor entered Italy. Mountain terrain should have negated radio advantage, yet FM proved even more valuable there. Multipath interference that crippled AM had little effect on FM signals. U.S. tanks coordinated through valleys and ridgelines where visual signals were useless, and German radios failed completely. 1st Armored Division reports described routine coordination at ranges where German sets produced nothing but noise. On June 6, 1944, as Shermans rolled off landing craft at Normandy, their SCR-58s maintained contact with naval fire support, coordination impossible with German technology. But hedgerow fighting exposed a fatal gap. Tank radios operated in the 20.0 to 7.9 MHz range, while infantry SCR-300 walkie-talkies used 40.0-48.0 MHz. The incompatibility meant American infantry could not warn tanks of Panzerfaust ambushes only yards away. Losses mounted in the bulkage until U.S. crews improvised. Field telephones, EE-8s, were mounted in ammunition boxes welded to hulls, wired directly into tank intercoms. By Operation Cobra in late July, this simple fix had revolutionized tank infantry cooperation. From July 25 to 30, 1944, Operation Cobra showcased the full power of American networks. The 2nd Armored Division, under Major General Edward H. Brooks, coordinated over 200 Shermans through radio nets that enabled unprecedented battlefield control. German defenders of Panzer Division faced an enemy that seemed supernaturally aware. American tanks responded instantly to reports from units miles away. Artillery strikes arrived within minutes of target identification. The contrast was stark. Panzer once Germany's elite armored division, was reduced to communication poverty. Most tanks had no radios, depending on visual signals in terrain where sight lines rarely exceeded 100 meters. The few remaining sets suffered from interference and limited range. The irony was profound. Germany had pioneered tank radios. Heinz, Guderian, architect of Blitzkrieg, had insisted on radios in every tank since the 1920s. His 1937 book Achtung Panzer emphasized communication as essential to armored warfare. Yet by 1943, German production could not meet the needs of his own doctrine. Production statistics told the story. In 1943, Germany built about 5,700 medium tanks, but fewer than 2,000 field transceivers. Many went to command vehicles and assault guns, leaving line units without communications. Soviet forces suffered even worse. Most T-34s entered combat without radios, relying on flags and pre-battle plans, disastrous against German units in 1941. Lend-Lease improved matters somewhat. US SER-508 sets were fitted to Soviet command tanks, but even by 1945 only 25% of Soviet armor carried radios. The contrast highlighted America's achievement. While the USSR struggled to equip a quarter of its tanks, the US achieved the 100% deployment of sophisticated FM systems. Motorola's Chicago factory embodied American mobilization. Before the war, it produced car radios. Wartime conversion required retooling and solving unprecedented challenges. Each SER 508 contained 2,748 precision components. The BC 604 transmitter alone used 4074 capacitors and 3085 resistors. Crystal oscillators had to maintain stability despite heat, cold, and vibration. The numbers told the scale: 3,800 SER 508s produced in 1942, 11,400 in 1943, and 24,000 in 1944 Sherman tanks built. No other nation came close. Beyond simple FM clarity, crystal-controlled stability allowed American tanks to preset channels before battle and maintain them under fire. German Ford 508s, by contrast, relied on variable capacitor tuning and drifted constantly off frequency. The dual receiver configuration allowed commanders to monitor both the platoon net and company command net simultaneously. Orders flowed instantly down the chain of command, while leaders maintained awareness of subordinate situations. The BC 606 intercom integrated seamlessly with the radio, enabling every crew member to alert the commander to threats. Throat microphones and noise-canceling headsets provided clear speech even in combat. By contrast, many German tanks lacked intercoms altogether, forcing crews to rely on shouting or physical signals. Power management gave the Americans yet another edge. The SER 508 operated on either 12 or 24 volts, automatically adjusting to the tank's electrical system. A dynamotor power supply provided filtered stable current that eliminated interference. German radios, drawing power directly from vehicle circuits, registered every spark and motor surge as static. The tactical advantage of universal radio deployment reshaped American doctrine. The combat command structure, flexible task forces organized for specific missions, depended entirely on reliable communications. U.S. commanders could create ad hoc battle groups from different units, confident they would coordinate through compatible radios. German officers, bound to rigid organizational charts dictated by limited communications, found this flexibility baffling. At the Battle of Arastut in September 1944, the 4th Armored Division faced multiple panzer brigades fielding superior Panther tanks. The Germans enjoyed advantages in armor and firepower, yet American coordination proved decisive. Every Sherman could instantly report enemy positions. Tank destroyers received targeting information from tanks beyond their line of sight. Artillery observers inside Sherman command tanks called barrages within minutes. Over 3 weeks, 4th Armored destroyed 101 German armored vehicles while losing only 41 Shermans, a 7-1 kill ratio that defied technical expectations. Throughout the war, German intelligence failed to recognize the root of American coordination. Reports noted effective communication but attributed it to discipline rather than technology. A September 1944 assessment read, "American tank units demonstrate good radio discipline and coordination." This appears to result from extensive training and rigid communication procedures. The analysis completely overlooked the technological edge. German tactics never adapt. They continued to target supposed command tanks based on antenna arrays, never realizing that every Sherman could function as a command vehicle. They laid ambushes assuming American units would falter once separated, unaware that FM radios preserved cohesion regardless of line of sight. By March 1945, as U.S. forces reached the Rhine, communication superiority peaked. The capture of the Ludendorff Bridge at Remagen showcased American speed in command and control. When the 9th Armored Division found the bridge intact, reports reached 1st Army headquarters within minutes. Within an hour, entire divisions were shifting to exploit the breakthrough. German forces, reliant on telephone lines already severed by Allied airstrikes, could not match the response. American radios created an impenetrable defense of the bridgehead. Tank platoons from different battalions integrated seamlessly, coordinating fires through their shared networks. German counterattacks, poorly coordinated and delayed, arrived piecemeal and were destroyed in detail. April 1945. The encirclement of the Ruhr pocket demonstrated the culmination of American communication superiority. Armored columns from the 1st and 9th Armies coordinated a complex double envelopment entirely through radio. Inside the pocket, 312,000 German troops were trapped in part because their communications collapsed. American fighter bombers, guided by radio-equipped forward air controllers, systematically destroyed German signal nodes. Wehrmacht units lost contact with higher headquarters and with each other. Field Marshal Walter Model's last messages before total failure captured the German plight. No contact with adjacent units, no communication with higher command. Fighting continued, but coordination impossible. American radio superiority shaped not only battlefield outcomes but also the psychological experience of tank warfare. U.S. crews fought knowing they were never alone. Even when isolated, they remained linked by radio waves. German crews felt the opposite: profound isolation. Cut off from one another, they fought individual duels inside larger battles. Otto Carius, one of Germany's most successful tank commanders, noted these challenges in his memoir Tigers in the Mud. Though he focused more on tactics than on the communication gap itself, the strategic implications were enormous. American advances of 1944-45 maintained relentless tempo because of coordination that German forces could not match. Patton's Third Army raced across France, powered by radio networks that kept control across hundreds of miles. German commanders consistently underestimated U.S. effectiveness because they could not imagine the scale of American communications superiority. Heinz Guderian, in his role as Inspector General of Armored Troops, recognized the problem but could not solve it. In a December 1944 memorandum, he admitted that American coordination erased German advantages in tank quality. After the surrender, U.S. technical intelligence teams confirmed what combat had proven. German tanks often carried better armor and weapons, but their communications were catastrophically inferior. U.S. Army Technical Intelligence Report number 206 concluded that German tank radios lagged 5 years behind American systems. The absence of FM limited distribution and poor electrical suppression created fatal weaknesses. Soviet evaluators reached the same judgment. Given access to captured German equipment, the Red Army copied American designs, not German ones, for post-war development. Production statistics underline the scale. The COS radios SCR 508 to 528 for 38 series over 50,000 units. Sherman tanks 49,000 3024 produced, deployment rate 100%, transmission power 25 while fire mission response time 3 to 5 minutes. German radios Fugue 5 transceivers Rauf 6,000 units. Medium heavy tanks Rauf 12,000 produced, deployment rate 20%. Transmission power 10 while frequency stability variable 5 to 1 in Dausch, range 0.51 mile moving 2 to 3 miles stationary. Fire mission response time 15 to 30 minutes. The radio superiority of the Sherman tank established principles that still govern armored warfare. Modern main battle tanks carry communication suites that trace their lineage directly to the SER 508, digital today but built on the same foundation of universal deployment and reliable coordination. When the Bundeswehr was rebuilt in the 1950s, it prioritized communications based on these lessons. Every Leopard tank rolled off the line equipped with comprehensive radio systems. A Bundeswehr training manual stated explicitly, "The defeat of superior German tanks by inferior American vehicles with superior radios teaches that information dominance outweighs platform superiority." Modern conflicts validate this lesson. In the 1991 Gulf War, coalition forces with advanced communications destroyed Iraqi units equipped with individually superior Soviet-designed tanks but crippled by inferior radios. In 2003, American forces again demonstrated that network-centric warfare defeats platform-centric warfare. The story of Sherman tank radio superiority represents a victory in the electromagnetic spectrum, one more decisive than any advantage in armor or firepower. German crews fought their war partially blind to this revolution, discovering too late that every Sherman was not just a fighting vehicle but a node in history's first battlefield network. The SER 508 transformed the M4 from an adequate medium tank into part of a greater weapons system that included every other American tank on the field. That transformation proved more decisive than thicker armor or a larger gun could ever have achieved. Every Sherman carried the true tools of victory, not only its 75mm gun or sloped armor, but 1 pounds of radio equipment that linked each crew to all others. This connection created a collective intelligence no individual German tank, regardless of design, could match. The Wehrmacht learned this lesson bitterly at Kasserine Pass, in the Italian mountains, across France's hedgerows, and in Germany's final battles. American tanks coordinated in ways German doctrine declared impossible without visual contact. The Germans never developed an effective counter because they never fully understood the technological gap. Field Marshal Wilhelm Keitel's supposed remark at surrender, "We knew how to build better tanks, but you knew how to make them work together," whether apocryphal or not, captured a fundamental truth. America had not simply built 49,324 Sherman tanks, it had built 49,324 nodes in the world's first armored battlefield network. What historians now call network-centric warfare began not in the digital age but in 1942, when the first Sherman with an SCR 508 entered combat. From that moment, warfare changed forever. The network would defeat the platform. The connected would overcome the isolated. The transformation was largely invisible to German commanders. They saw American tactical superiority, but failed to recognize its technological foundation until far too late. By the time they understood that every Sherman carried communications capability most of their tanks lacked, the war was already decided. The German failure to grasp and correct this weakness stands as one of the greatest intelligence oversights of World War II. Despite countless engagements demonstrating U.S. coordination advantages, German leaders continued prioritizing superior hardware over communications. They built tanks that fought as individuals, while America built tanks that fought as teams. In the end, the invisible waves carried by SCR 508 radios proved more decisive than the deadly shells of the German 80. The ability to coordinate, to share information instantly, to act as a unified organism rather than isolated vehicles. This advantage determined victory more surely than armor thickness or gun caliber. The Sherman's radio superiority changed warfare forever, establishing a principle that still governs battle in modern combat: connection equals survival and isolation equals defeat. German troops learned this truth across 3 continents, only to discover far too late that American superiority lay not only in numbers, but in mastery of the dimension that mattered most: the power to fight as one.